Hello everyone. In this video I will explain MAC stands for medium access control. This medium access control actually states that there is a single medium which is going to be shared among multiple nodes. Now if multiple nodes start transmitting at the same time, this will result in a collision. So medium access control, these protocol also actually specify how these node going to transmit at what time, so that the number of collision will be minimum. So in this video I'm going to explain pure Aloha and slotted Aloha. So before discussing those two protocols, let's see two broad categories of medium access control. So we are having two broad categories of MAC protocols. First one is contention based, second one is contention less. So contention based, these type of protocol actually, they actually allow different nodes to contend for the network access. So all protocols lies under contention based categories. Those protocol actually allow existence of collision. Let's take one example for understanding contention based protocol. Let's say there is a group discussion activities going on in a room, and in that activity there is no coordinator. So whenever a person wants to talk, he can talk. So in that scenario it might be possible that multiple persons start talking at the same time. So similar situation, if you think in network, if multiple nodes want to send some data and if they start transmitting at the same time, there is a possibility, so there will be a collision. So all protocols which actually allow existence of collision, those protocol actually comes under contention based. Another category is contention less. So this contention less category, it states that there won't be any collision. So let's take our example which we have taken for contention based. Now consider same group discussion activity is going on, but there is a coordinator, and the role of that coordinator is that that coordinator actually specify which person will talk at what time. So initially, let's say that coordinator is asking first person, do you have anything to say? If yes, start talking. So in that case, in that this situation, there won't be possibility of interference. Everyone will speak one by one. So similar situation, if we think in network, so there will be a coordinator. So if there are multiple nodes which want to transmit some data, that coordinator will grant permission to node one by one, and then those node will start transmitting. So our pure Aloha and slotted Aloha comes under contention based because there are collision as well. So let's first discuss what is Aloha. So Aloha is a contention based protocol. It means under this protocol collision can be occurred, and this protocol says that if a node wants to transmit a data, it can transmit at any time. Whenever a node is having data, that node can start transmitting that data at any time. There is no constraint on time. So we are having two versions of Aloha. First one pure Aloha, second one slotted Aloha. So let's have a look on pure Aloha. So let's say we are having three nodes in a network. So in Aloha protocol, length of packet is fixed. So whenever a node wants to transmit any particular data, that data actually divided into fixed length of chunks, and those chunks are our packet. So in Aloha protocol, length of a packet is fixed. So if a data is exceeding that length, that data will be divided into smaller chunks of that size. Node can transmit at any time when they want. So let's say A start transmitting, B start transmitting, C start transmitting here, then again A start transmitting here. So a node can transmit at any time whenever they want, and whenever multiple nodes transmit at the same time, this will result in a collision. So this axis is representing time. So if you can see at this time, A is already transmitting its data and B also start transmitting data, and multiple nodes transmitting data at the same time, this will result in a collision. So these two frame will be collided, and this frame will not be received by its receiver in correct form. So what you need to remember about pure Aloha: packet length is fixed, plus a node can transmit its data at any time whenever they want. Now the question is that what will happen if there is a collision, and how a node would know there is a collision in medium or not. So in order to find out whether there is a collision in channel or not, there are two options. First option is that feedback property of broadcast channel. A broadcast channel is a channel whenever any node transmit any data, any information in that channel actually broadcast that information to every node, and the node who is the actual receiver of that data, that node will receive that information. Other node will discard that information. So if a node is transmitting some information, other node can hear that transmission. So in that case, if a node can hear multiple transmission at the same time, if a node can hear its own transmission plus someone else transmission as well, in that case that node will conclude that there is a collision. Second option is that use of acknowledgement, like sender will send a data to receiver, receiver will reply by sending acknowledgement that your packet is received successfully. In case if there is no acknowledgement received, it will be considered as that packet is lost in medium because of collision. So I'm again briefing. Whenever node is ready, they are allowed to send. If there there are no other, this is actually wrong. If there are no other frame transmitting, then first frame will be delivered successfully. The meaning of this second point is that once a frame is transmitted and during its transmission period, if there is no other frame is transmitted in medium, so in that case that frame will be delivered successfully. If collision is there, then node waits for a random amount of time, then again transmit. Now you might be thinking why a node has to wait for random amount of time. So let's consider this scenario. Node A and node B wants to transmit at the same time, and they start transmitting their data, and they find out that there is a collision at the same time. So if they again retransmit their data immediately, it would result in a collision again. So in order to avoid that possibility, every node uh, has to wait random amount of time to avoid that repetition of collision. And this is the pure Aloha algorithm. From here it will start back off to 0. So what is back off? It actually is set. Let's say initially that set is having only two values, 0 and 1. So before this one, this back off is 0, is set without any value. There is no value initially, or you can consider 0. So it will send the frame. Once that frame is sent, it will wait. Why it has to wait? If there is a acknowledgement mechanism is used, in that case sender will wait for acknowledgement. And in case if broadcast feature of channel is used, that sender has to ensure that the packet has been delivered to the target successfully. So there will be a wait. So if acknowledgement received, or that frame is successfully delivered, in that case success. If no, it means there is a collision in medium, increment back off. So this set will be increased, and then there a number will be picked from this set randomly, and that number will be multiplied with the time that is required to transmit a frame from one node to another node, and that node will wait for that amount of time. Now It might be possible that a node is sending some data, there will be a collision, again sending, collision, again sending, collision, again sending, collision. So meaning of this situation is that there is a lot of congestion in network. So in that case, after a particular number of attempt, whenever that attempt will exceed the limit, so this will check whether the limit is exceed or not. If yes, in that case, abort, don't transmit any data, because there is a congestion. In case if this limit is not exceeded, wait, back off time. So this is the algorithm used for pure Aloha. uh, Now here we will see how to calculate throughput for pure Aloha. uh, let's say this is the frame, and in this frame required time t to transmit from one node to another node, and we want to see what is the throughput. So if you can see, during transmission of this frame, if we want to avoid any possibility of collision, so there are two possibility of collision, let's consider them first. So if a frame is transmitted in this period of time, so if a frame is start transmitted in this period of time, it will end somewhere here. So it would be uh, a collision. And another possibility is that if some node start transmitting data in this duration, let's say someone has started its data transmit from here, so it, let's say like here, so it would be again collision. So if you want to deliver a frame successfully to destination node, we need a constant that in these two time intervals no frame should be transmitted. So with this constraint, we will see what will be the throughput of pure Aloha. So here we are saying vulnerable period of length of 2 frame time. So this is the vulnerable period. So all frame have fixed length of 1 time unit. So these are the constraints used for modeling. We are considering 1 time unit and infinite user population. It means there are number of nodes which are going to share that medium is infinite, and offered load. So rate G actually will represent what is the load of network, and load will include transmission of data, what is the current transmission rate. And there is a formula, this formula can be used to find out probability for sending k packets in t frame time. So now let's have a look on pure Aloha throughput calculation. So throughput can be considered if we are, if this is the current load, let's say 100 frames are transmitted in a particular time period, and if this is multiplied with the probability of no collision, if during that transmission if there is no collision, if we multiply that probability with the offered load, it will give us throughput. So probability of no collision, we can write same statement again, like probability that no other frame is transmitted in vulnerable period. So vulnerable period, we know that this is 2 frame time. So we can write again probability that no other frame is transmitted in 2 frame time, and again we can write probability that 0 frame transmitted in 2 frame time. So in previous slide we have seen the formula to calculate probability. So that formula we will use to find out probability of transmitting 0 frame in 2 frame time. So this is the formula. If we put, so k frame, so here we want to see for 0 frame and t frame time, which is 2. So if we place this value like k by 0 and t with 2, so we will get this expression. And if we simplify this expression, it will give us g multiply e to the power minus 2g. So this is the formula for throughput. Now we want to see what is the maximum throughput a pure Aloha protocol can achieve. So here we will use maximum minima mechanism. We will differentiate this equation and we will put it equal to 0. So when we differentiate it, we will get this expression. We will put this expression equal to 0, and what we will get this expression, and this expression will give us z equal to 1 by 2. So it states that whenever load is 1 by 2, it means if the net 50% network utilization is there, at that case pure Aloha will provide maximum throughput. So when g is 0.5, throughput will be maximum. And now let's see what's the maximum throughput when g is equal to 1 by 2. So here we will we will replace this g by value 1 by 2, and what we will get? We will get 0.18. So this is the maximum throughput of pure Aloha. It meaning of this one is that if 100 frames are transmitted with the help of using pure Aloha protocol, only 18 frame will be delivered successfully, and it will give us maximum throughput when g is 1 by 2. Now let's see what is slotted Aloha. So in slotted Aloha, can be considered as an advancement on pure Aloha. In pure Aloha, a node can transmit data at any point of time, but in slotted Aloha, time is divided into particular slots, and every node can transmit only in the beginning of slot. So here also we are having fixed length packet, and we are having time slots. So now let's see here. So this is the time axis, and this axis is divided into time slot, and every node, if a node wants to transmit any data, that node can transmit only from the beginning. Now let's say node C wants to transmit at this point of time. So slotted Aloha says that in the mid of any time slot you cannot transmit, you have to wait for next slot. So C has waited for next slot, and from here onwards C has started its transmission. So this is the slotted Aloha. And here if you will see region for collision, when there will be a collision, when two nodes transmit their frame in same slot. So let's say station 1 is transmitting in first slot, 2 is transmitting in second, and third and 1 again transmitting in fourth slot. Station 1 transmitting in fourth slot second frame, and 3 is transmitting first frame in this slot. So this will be result in a collision. Here also if you can see, two frames are transmitted in same slot, so this will be again in collision. So these are the bullet point of slotted Aloha. Time is divided into slots, and this slot is equal to frame transmission time. A station can transmit at the beginning of the slot only. So if a station misses the beginning of slot, it has to wait until the beginning of next time slot, and a central clock or station inform all station about the start of each slot. Maximum channel utilization is 36%, and we will see how this 36% is calculated. So here if you will see vulnerable period, so if a frame is transmitting here, the only possibility that there will be a collision, that if some other node start transmitting its own frame in the same time slot. So for slotted Aloha, vulnerable period is only one time slot, only one time slot. So if we use this the previous formula with slotted Aloha value, what we will get? We will get this expression for throughput, and if we do the same process for calculating maximum throughput value, so what we will get? We will get G value equal to 1. It means when the load is 100%, in that case slotted Aloha can provide maximum throughput. And when we replace value of G by 1, we will get 0.36. So slotted Aloha offer double throughput as compared to pure Aloha. And this is the throughput provided by both protocols. These are the advantage and disadvantage. Advantage, it's very simple to be implemented. There's no master station is needed, and if there is only one node that has to transmit its frame, it can utilize full rate of channel. Now, what is the disadvantage? Disadvantage is that if m nodes wants to transmit and r is the bandwidth, so Aloha would not offer r by m speed to every node, because there will be number of collision, because the throughput for Aloha is only 0.18, so it's very low. So it's not good for a channel where the number of user is very high. Thank you very much for watching.